Okay, good morning, everybody. So today we'll be talking about the concept of serverless architecture and specifically the concept of Lambdas, AWS Lambdas. So this is a new trend in the architecture, especially in the cloud architecture. So far we talked about EC2 instances, servers. We provisioned hundreds of servers so far, and we talked about auto scaling group and how load balancer works, how all of them fit together in the concept of VPC and all. So with Lambdas, the whole concept of Lambda itself, right? So this is part of the whole serverless architecture. So what it means is a piece of code that's written by you will just upload a piece of code into cloud without you having to worry about the servers. So you don't have to worry about provisioning the servers. You don't have to worry about the operating system level patches. You don't have to worry about auto scaling. You don't have to worry about the fact that there are servers that run your code. You just focus on your business domain. You write code to solve your problem. Upload your piece of code somewhere in the cloud. In this case, it's AWS. And then set up your triggers, meaning when should that code be run? That code will be sitting out there. It will not be run all the time. So there should be some trigger. So that's where the concept of event-driven architecture come into picture. So these fit nice into the whole event-driven architecture very nicely. So a piece of code will be running somewhere. Okay. In fact, it will be sitting out there when an event gets triggered. That's when your piece of code will get executed. So at that time, your piece of code will be taken out. Behind the scenes, it just creates a small, runtime environment and deploy your piece of code and kick off your code. So there are, of course, servers under the hood, but you don't have to worry about the servers. So no more EC2 instances. You don't have to worry about scaling them up. It will automatically scale. So there are no servers from all practical purposes. From your point of view, there are no servers that you need to worry about. So let's step back and talk about the whole computing, how the computing has evolved the last couple of decades, right? So you all know, probably most of you know, where servers, we used to call vendors, and then, hey, I need to spin up a couple of database servers for this. And then they just take your details, your requirements, and they just send you invoice, and then they'll kind of provision the servers and ship the servers in a month or so, in a couple of weeks or a month. So we have seen that architecture where the physical servers existed. And later, we saw the concept of virtualization and how virtual machines have come into place. So with the concept of virtual machines, what happens is on a single physical server, so you will be able to provision multiple virtual machines, and each one can have its own operating system. So we saw that virtualization. And then we saw the concept of containerization coming into the mix, coming into the architecture in the recent times, probably 6-7 years back. So they have taken this concept of Linux containers. So why did Linux containers come into picture? It's because the virtual machines. Okay, virtual machines are great, but every virtual machine has an operating system. Do I need the baggage of the operating system on every single one of them? Yes, one physical machine can be virtualized into several VMs, but do I need really the operating system across all of them? My tech stack is pretty well defined. Mine is pretty much, let's say, if I have a Java-based technology stack, I don't need operating system 10 across 10 virtual machines. I know that they're all there. All I need is pretty much JVM. So the concept of container came in, and then they actually virtualized at a different level. So you'll be having a single operating system, but they actually virtualize the ports at a different level using the concept of the Linux containers. They're very lightweight. They're great. And Docker popularized it. And then Docker containers have arrived. And the Docker containers are actually, there's a new concept called, you got the containers, the concept of containers. So now, how about the container orchestrations? Meaning, there will be a God on top of the containers saying how many containers should be running, when to scale up, when to scale out, when to scale down, and all that. So the technologies like Kubernetes fit in there, right? So that has evolved. And now the next level in this journey is the complete serverless itself. You don't have to worry about even the containers. You don't have to worry about the servers. You don't have to worry about the containers. You just write your piece of code and just upload it. In all fairness, Google has brought this concept before everyone else. In fact, if you look at the cloud industry, Google had this concept of GAE, Google App Engine. I played with Google App Engine back in 2009, 2010 area. Even before that, probably. Wrote a simple server-based application and deployed it, and without having to worry about any servers in the cloud. Okay, so Google actually brought this much earlier into the architecture. So the way AWS has taken it is that AWS went into the core infrastructure as service level. So what Google envisioned at that time was that, there's no point in having about this whole server concept. Okay, let's talk about purely the serverless. But the timing was not so good, because there are a lot of legacy applications. Because when you talk about serverless, you have to go with a specific application architecture. It doesn't work with everyone. So there are a lot of applications out there, like legacy EJB-based applications sitting in a big fat enterprise archive file, EAR file, or right? So they can't be ported as is. But with the infrastructure as service, the way AWS has taken the industry, so with infrastructure as service, pretty much they're giving you the virtual machine, and then you don't have to worry about. You bring your own everything. You bring your own platform. You do whatever you need to do it, right? So, anyways, that's the evolution. So we went from physical servers to virtual machines to containers to pretty much complete serverless. So here, again, to reiterate, you write a piece of code and then just deploy somewhere, and you just enable the triggers. You just configure it. Okay, when should this code be run? What event should make this code be run? That's it. So that is the concept of AWS Lambda. So Lambda provides that serverless platform where you will be able to upload your code, and then you can set up your triggers, and you just done with it. So this is so great that let me walk you through some of the use cases actually. So you will understand what exactly happens. So we've been talking about this weather service, right? So we did the poor man's weather data upload. Like I have a CSV file with all the weather information. Our analyst will get the data a couple of times a day. And as soon as she or he uploads the data into a specific bucket, I want my code to be run automatically rather than me triggering through a REST endpoint. I want my piece of code to be run when HTTP put is called on this particular bucket. When a new object is added on this or an existing object is updated, I want my piece of code to be run. That's an event-driven architecture, right? And this piece of code will get all the details. It will say that, okay, what bucket, and what's the object key. And this piece of code will go to S3, get the data, parse it, and then dump it into the database. So that your API will always return, because API is reading from your database table. So your API always returns proper information or up-to-date information. So that's the use case we will be doing it today. So your code will be automatically get triggered when a new file or existing file, new object or an existing object is updated or created in an S3 bucket. But that's not the only one. We'll be talking about the concept of API gateway tomorrow. So with the API gateway, so the whole concept of serverless website comes into picture. Pretty much there is no server. So when you call and when you make an API call, there is a front guy sitting there. That guy's name is API gateway. So API gateway will take the request and he will trigger the Lambdas. So Lambda is just a function sitting out there in the cloud that's ready to get triggered. So that's why it comes under a concept called function as a service. You guys have heard of infrastructure as a service, the lowest level, and then on top of it, you heard the platform as a service, and then software as a service. So this comes under somewhere as a function as a service. It's about platform without you having to worry about the servers. Okay. So Google has the Lambda counterpart. It's called Google Function, if I'm not wrong. Anyways, so let's go and understand what it is, and then let's look at some use cases. These use cases were mentioned in the AWS documentation itself, so I pulled it, and we'll go over it, and then we'll jump into the examples. So AWS Lambda, it lets you run code without provisioning or managing service. You don't have to worry about it. So you pay only for the compute time you consume. That's the beauty about Lambdas. It's a sub-second billing. It's not even per second billing. They calculate based on 100 milliseconds. So if your code run for 5 seconds, so AWS is going to charge you for 5 seconds. So if your API will only be called 5 times a day, then you are paying only for that. You are not paying for the EC2 instance for 24/7. That's the beauty. Okay, just upload your code and Lambda takes care of everything required to run and scale your code with high availability. Yes, it knows the availability also, meaning it will automatically put it in different availability zones. So concurrently, when 3 requests come in, it knows how to distribute your load across the availability zones, so that you're not putting all the eggs into one basket. If one availability zone is down, it takes care of availability. You don't have to worry about it. Okay, and you don't have to worry about scaling. It will automatically scale. It can let your API get 5 requests per second or 5 million requests per second. You can configure your Lambdas to handle that load automatically, and you don't have to do anything. You don't have to worry about auto scaling rope, anything. It will do it. So you can set up your code to automatically trigger from other AWS services or call it directly from any web or mobile app. Yes. So in a typical websites or web APIs or mobile APIs, let's say you are building a mobile app. Yeah. Mobile apps, what's it? You have a skin on your mobile phone, but everything else is pretty much REST endpoints, right? So your mobile app makes a RESTful endpoint that goes to your API gateway. The concept of API gateway is nothing but it's a front gate for all of your APIs. So the API gateway takes your request and trigger a Lambda. So you're not paying for the code when it's not running, like in the EC2 instances, right? So here you'll be paying only for the instances when your code is actually done. So that's your mobile app, even web app, same way. And also, another example that I mentioned is you can have other services trigger your Lambda, meaning your S3. When when an object is deleted, trigger a Lambda. When an object is put, delete a Lambda. So with this concept, starting from today itself, after you understand the concept of Lambda, go back to your offices and then think about where can we leverage this. You don't need to bring the complete infrastructure into cloud. Think like an architect and then say, in this specific case, we have this particular scenario, this gets triggered. How about taking this particular piece of code into cloud and deploy it as a Lambda, and then whenever trigger happens, whenever there is an event gets triggered, we'll run that piece of code. So think about it. So it comes under function as a service category, and it's a great tool for event-driven architecture. So let's look at some use cases. Okay, it's pretty. I picked all these use cases from the AWS documentation itself. So take a look at this one. So a photograph is taken. So the photograph is uploaded to Amazon S3. Photo is uploaded to an S3 bucket. As soon as an object is uploaded into S3 bucket, your Lambda gets triggered because that's how you configure it. This is where your piece of code is. Okay. Lambda runs image resizing code. So you wrote a piece of code to take the original photograph and then you're resizing it based on various form factors for your mobile devices, for your iPads, for your laptops, desktop computers, etc. See here, photo is resized into web, mobile, and tablet sizes based on your form factor, and then you're storing them somewhere. Make sense? So this is in a perfect event-driven architecture. Let's take an additional one. This is a web application use case that, again, Amazon has taken. Amazon S3. Front-end code for weather app is hosted in S3. Okay, this is your static website hosting within S3. Okay, you have your static website hosting within S3 with all the JavaScript files, CSS, images and all. And now you click on a button, user clicks to get local weather information. You just click on that. Now this goes to your front gate for all the APIs called Amazon API Gateway. So that API Gateway will trigger your Lambda, and your Lambda will go fetch the information either from relational database like your MySQL or from DynamoDB. That's a non-relational database. This is even better, getting it from non-relational database, because DynamoDB itself is a serverless. That's the beauty. You will not be paying for the entire underlying EC2 instance like in your RDS. So take advantage of this. This is the complete serverless. See here, beauty here is that Amazon S3 itself is a serverless. You are not paying. This will automatically scale to any level Amazon S3 website. You know about it. There are no servers that you have to worry about here. API Gateway, There's no servers here. It's just acting as a front gate guy, applying some policies, authentication policies and all, and then it triggers your Lambda, and your Lambda is complete serverless. DynamoDB complete serverless. It's a complete web application with 0 servers. You do not have to worry about it. Every one of them will automatically scale to infinity. In fact, if you ask me, this must be your, you should try to build a website like this. With all the group here, you should really try to build it. It's that simple. Okay, let's take a look at the other one. Oh, this is Internet of Things, IoT backend. So let's say this tractor has several sensors there. So tractor sensors, they send data to Amazon Kinesis. So Kinesis is a streaming service, Amazon's streaming service. So this guy through Kinesis Firehose and Firestream, it takes the data. Okay, it takes the data coming from all of these sensors and then gives the data to Lambda by triggering a Lambda. Okay, it captures and streams the sensor data for processing by Lambda. So Lambda is going to take the data information across all the sensors, and then Lambda runs code to detect trends in sensor data, identify anomalies. Let's say there is a higher temperature in your radiator. So radiator temperature cannot exceed 90 degrees Fahrenheit, but this sensor send me 110 degrees. Okay, something is wrong. And then I will look at the data, the corresponding data coming from other sensors also. Okay, and then my Lambda will understand what does this mean. Okay, 110 degrees in radiator, what does this mean? Then maybe I need to replace it. I'll automatically place an order. Order is automatically placed for replacement parts. Absolutely. In fact, forget about these IoT based and web-based and mobile-based applications, right? When you say Alexa on any Alexa-based devices, any Amazon Alexa-based devices, when you say Alexa, what's the weather? You are triggering a Lambda. So when you say Alexa, what's the weather? Then it's actually making Lambda gets. So that internally triggers Lambda. It actually makes an API call, okay? And that triggers Lambda, and that Lambda will make, will get the data from some service and then give it back to you. So that's a perfect Lambda. Okay? This is a mobile backend. It's the same stuff. I can go on and on and on. So user posts status update. So this is like a Facebook-like application. User posts a status update. So it called Amazon API Gateway called Lambda. And then Lambda sends a notification, SNS notification. Status update notification is pushed to user's friend. Okay, let's say I have 100 friends, okay? And then what Lambda did is, essentially it identified all the friends of Venkat, the 100 friends, and then triggered an SNS, and SNS responsibility is to send notification to all of my friends. So my status update has been notified to all of my friends. Lambda, serverless. Agree? So who all can trigger Lambda, by the way? Well, so you will understand, I know we didn't talk about a lot of this. We don't need to really, but who all can trigger? I'll tell you, especially from the exam perspective. This single question is for the exam. So who all can trigger Lambda? Well, your API gateway can trigger Lambda for all of your web APIs, REST APIs, mobile APIs. Okay. And your IoT can trigger your Alexa skills kit. When you say Alexa, that triggers Lambda. Okay. Your application load balancer can trigger a Lambda. Your CloudWatch logs can trigger Lambda. So let's say you found an exception, a specific exception that you are looking for in a CloudWatch logs. when that particular exception is entered, then you want to trigger a Lambda, and that Lambda can do anything. Well, Lambda may provision another service using API, okay? Or that Lambda can restart something, or that Lambda can order something else, okay? So you can do anything. So DynamoDB, yes. DynamoDB, as we understand, it's a non-relational database. It's a NoSQL database. And when you create a new record in a specific table, they have the concept of table. In the NoSQL world, you have a concept of table and an item. So when a new item is equivalent to your row in your relational database, okay? So when a new item is created, you can have Lambda trigger. But you cannot do that with RDS. You cannot trigger a Lambda with RDS, meaning when a new row is created in a database table in RDS, you cannot have Lambda triggered, but you can do that with DynamoDB. And of course, S3. We are going to see this with an example, S3. So when my analyst uploads new weather information, I want my Lambda to get triggered because that's how I'm going to set it up. And then it will automatically get the new data and then push it on. So your simple notification service and simple queue service can do it. Kinesis, your file stream can do that, and more. Make sense? But the main important point here is that you want to understand that RDS is not one of them. It's a direct question in the exam, so that's why I wanted to show that. Okay, with that said, that's enough theory. So let's dive in to examples. So let's take a look at it. Yes, go ahead, Shravan.
Yes, see, when you said before that the Lambda is a piece of code, is a function. Okay, see, what I understand by a piece of code, is, of course, the Java Web Services programs and also some programs that read and write from tables or read and write from text files. Right. Over there, you will need a lot of data store, and you would need auto scaling and all those things. Does it cover that kind of code, Lambda?
Lambda, you can write anything. We will be actually. Let me not explain that. Okay. So let me go ahead and show you the examples. With these examples, you should get an idea what it is. Okay.
Okay.
So let me show you that without. Let me not answer that. So let's look at the examples. So go to services Lambda. Okay. Create a function. This is a function. So now I'm going to call this as my first function or something. Yeah, my first Lambda function. My first Lambda function. Okay. So runtime. This function. What runtime are you using? These are all the runtimes that it supports. It supports Go, Java, Python, Ruby, Node.js. Okay, and these are the environments. So I will pick Node.js to start with. I wanted to show you how simple that one is, because with the Node.js, what you can do is you can use online editor. Okay. And I'm going to show you next, all of my subsequent examples will be based on Java. Okay. And we'll be going pretty deep, so you'll understand, Sean, what I'm saying. Yeah. So this is my first, this is how it looks, and you can author from scratch. Okay. And there are some blueprints out there. Let's say you want to expose an API. So there are some blueprints out there. We will see when we talk about API gateway. Okay. So go ahead if you have a specific question, Sean.
No, nothing.
Okay. Create function. So I'm writing a simple function, my first Lambda function in Node, whatever that version that it gave. Okay. So this is how it looks. So the top portion is designer section, and this is where you can attach the triggers. So who can trigger this particular Lambda? Well, let's not worry about it. First, let's worry about the code. What does our Lambda does? This is an online IDE, pretty much browser-based IDE. You can use it for Node.js or something, even for Node.js, it's for something simple. You can use online IDE. But if it's something like Java, then unfortunately you have to pretty much write your code in your favorite IDE, like Eclipse, and then upload your jar file into it. Okay, we can take a look at that one also. But this is your Node runtime, and then this is where your piece of code will be, and then your environment variables. Do you want to provide any environment variables to your code? That depends on it, and any tags for your piece of code, and then some basic settings here. So your Node.js 12.x is what the runtime environment is, and it's providing 128 meg memory. Okay, so you can change this. What's your memory requirements? So for your Lambda function, the only parameter that you need to provide is how much memory do you need. That's all. You can't specify how CPUs or any of that, because everything else will be automatically calculated and provided to you. So this is your handler, meaning in your index.js file, index.js file, and your method name is handler, right? See here, where is it? Index.handler, meaning in this class. In a Java world, right, you can say that fully qualified class name and method name. So your package name dot class name, Java has slightly different syntax, : method name. But in the case of Node, you have this file name dot your method name. Method name is handler. If you change this one to test, here exports dot handler, right? This one, if I change this to, let's say, test, then I need to change this information here. Okay. And monitoring tools, do you want the default monitoring or do you want active monitoring? Actually, the default monitoring is monitoring using your CloudWatch, okay? But if you want active tracing, meaning you want to look at all the request payloads, response payloads, all of that, then you can go, use your active tracing, and it's an additional charge. But you can use Amazon service called AWS X-Ray. AWS X-Ray is responsible for, showing you the complete trace. So especially with Lambdas, Lambda feels so beautiful, and it's pretty good. It makes your life easy with the event-driven architecture. All of that, no doubt about it. Okay. But it actually brings a lot of complexity to your architecture also. It's not a tool for every single problem. Mainly because it's your path of execution is lost, because everything is an event, right? So, your S3 calls, S3, when you drop a file in S3, it gets, it's triggering Lambda. Your Lambda is doing something and it can trigger another Lambda. That Lambda can send an SNS notification. It can be messy. So you can easily complicate things. Okay. So please understand that. And then if you think you are complicating the things, then probably go for active tracing with X-Ray. With X-Ray service, you'll be able to look at the tracing all the way from the request initiation to to the end. So by default, it's not attached to a VPC, but if you want, you can attach to VPC. I will leave it as is. And then file system. If you want your Lambda to connect to a file system, you can do it, but you need VPC for that. And concurrency. So you can use the default unreserved account concurrency at the account level. At your account level across all the Lambdas, you have 1,000 concurrent requests. That's your limit. Okay, but if you know your typical concurrency limits, then you can threshold them. You can pretty much see here, to enable your function to scale without fluctuations in latency, use provision concurrency. So with the provision concurrency, what you can do is you can throttle your request. So you can say that, hey, I don't want to handle more than 50 requests. Because what happens when 51st concurrent requests come in is your code will be brought out by Amazon, and then it will provide the runtime environment, and then just deploys your code, and then run your bootstrap, and then call your method. So it does that behind the scenes. So you will see a slight delay. If you leave the default settings, you might see a slight delay, because every single time what is happening behind the scenes is that behind the scenes, it uses the same containerization technique. So it creates a simple micro container with your 128 meg memory. It creates a container. Okay. When a first request come in, it will see, do I have a container for this Lambda function? No. Then, okay, it takes the Lambda function, that code that you wrote. Okay. And then it will understand what runtime it is. So it creates a simple container, and then deploy your code and warm it, and then give your request or call your function. Okay. So, and it's going to leave it there for 5 minutes, that container. So if a next request come in within the same 5 minutes, then it's going to reuse the container. If there is no request within 5 minutes, then it's going to destroy the container, so that you are saving the money. That is how AWS is able to charge you only for 100 milliseconds of your real compute. Meaning, if your code is running, it will charge you. Otherwise, it will not charge you. So the point is, you can use your provision concurrency. You can put a throttles there, and you can just kind of edit, and you can say that, nope, I need only 100 concurrent requests for this particular Lambda. You can update. Okay, I'm just leaving the default, but I wanted to show you that. And yeah, your asynchronous invocation. Pretty much, if something goes wrong, where does this go? Your dead letter queue, and then how long do you want the messages to be stored in the queue, and all of that. If you want your Lambda to connect through to a database, you can actually go through the database proxies also. You can create the new database proxies. So anyways, so let's go back. This is all Lambda function, Lambda, different attributes, right? So now what we'll do is, let's go back, and this is my function name here, handler method name, and then it's an async, and then I just created a constant here. It gave me the code, right? It created a constant here. Response status code 200, body is hello from Lambda, and just returning it. Yeah, it's simple. Okay. And if you want to log it, you can even log it. You can say that. Just say console.log, like your console.log, my first Lambda function. Lambda function has been called. Okay. And then you save it. Save the function, and now my function is there in the cloud. And now, okay, how can I test it? Before I talk about triggerings, okay, I want to unit test this piece. How can I do it? Well, they provided a nice feature here. See here, you can create a test event. So see here, guys, event object is what pass it to your method, right? So configure test events. So by if you can change this one, but this is a JSON object. So here you have key value pairs, key 1 value 1, key 2 value 2, key 3 value 3. So this will be passed as an input to your method. Okay. And what I will do is my unit testing. I'll call this as test 1, and then I'll just create it. Okay. So now I just created a simple, test case, and then let me go ahead and test it. When I tested it, you can see the execution results here. Okay, I got the response. Status code 200, body hello from Lambda. So if my Lambda gets triggered, this is the response I'm getting it. See, I'm getting the response. This is a simple method or function based on whatever the programming language you're coming from. So it takes an input and it spits out some response. That simple. Okay, so take a look at this one. This is the response, and this is the request ID. And look at your logs, your function logs, info. My first Lambda function has been called. My console log has been printed. Okay, sure. It's printed here, but I want to see these logs. I want to see these logs in CloudWatch. Okay, I can click on these logs, and it will take me to CloudWatch. I'm going to show you that. Yes, Sean.
Yes, actually, you sent 3 inputs, right?
What's that? I said
in the test one,
an object with 3 key value pairs in the event.
Okay.
But it doesn't matter. I'm not checking what the input is, right? Here in this code, I'm not checking anything. I'm just returning some dummy response.
Okay.
So what I can do is let me print my event, the whole event object itself. Event object is, let me print that, okay? And then let's save it and let's test it. And then look at the logs. Event object is object. Huh? I wanted to see the whole, whatever I passed my key value pair, not in an object format, but there you go. See this one? I passed key 1, value 1, key 2, value 2, key 3, value 3. So let me change my test case. I'll just say, let me say I'm passing first name. My Lambda is taking this as an input, okay? Save it. This is my test case. And let's go ahead and test it again. And this time you will see that my first name is Venkat, last name. So whatever the total event object has been printed here. Your event.toString has been printed. Okay. So this is what I can show you. This whole thing is the input for my function. Make sense? This is one test case. And then, so what you can do is you can, if you want, you can get event dot, and you can get this, event dot, get the first name, event dot, you can get the last name, you can get all of that. Okay. Make sense? Now I wanted to show you a couple more things. One is logs. Let's go take a look at the logs. So it takes me to CloudWatch, or you can directly go to services and go to CloudWatch. When you go to CloudWatch, go to log groups. This is my first Lambda function. This guy creates a log group for each one of them. So these, I have 3 streams here. So let's take a look at the latest one, which is this one. See here? First name is Venkat, last name, and before that, yeah, we triggered one more time. So this is your logs, your function logs. Make sense, guys? A simple one. And then, by the way, by default, what it does actually here is permissions. Did I provision? No. So let's go top here, permissions. So click on permissions. So when you create a Lambda, actually in the first screen, when you create a Lambda, it was asking, hey, what do you want me to do? Do you want me to create a new role, or do you want to use an existing role? Because you have to give some permissions to your Lambda, right? What permissions? It's all up to you. But in our case, we said, please go ahead and create a new role. See, it created this particular role, my first Lambda function dash role and some name, right? So click on that and then it will take you to the role. So this role, see this one? It gave a policy called AWS Lambda basic execution role. So every Lambda function, you want to give this particular policy to a role and assign that role to your Lambda function. Okay, what's this AWS Lambda basic execution role? Essentially, you are allowing, creating the log group, and you are allowing creating the log string. That is why our Lambda function was able to write to the logs, okay? So if you remove this one, then your logs will not be written. I just wanted to put it out there. Any questions so far? A simple Lambda function based on Node.js. Very, 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 very simple.
One quick question.
Sure.
So can we see anywhere where this particular server is created, or EC2 instance, or
Nope.
Where it is? Okay.
You have no clue. Because behind the scenes, it's not even EC2 instance. It's using it creates containers. Okay, of course, but those containers are also created in an EC2 instances somewhere, but we have no clue about that.
But in the logs, we could see that the log is created in East Zone 2 kind of thing, right?
Yeah. No, you know that your function is created in US East, Ohio. That you know that.
Okay.
Okay, that you know that. Because if you want, you can attach this to a VPC, right? So this guy will tell you. So if you want a custom VPC, then see, these are all the VPCs in your Ohio region. So you know that this function is created in Ohio region, but what EC2 instances, you have no idea. You don't know anything more than that. Make sense?
Yeah. Does it really matter where we create this, in which, because you may or you may not really associate this to a VPC, right?
Yeah. You may or may not have to see when will I associate this to a VPC? Well, if I want to apply any of those, once you associate this to a VPC, my whole, it has to go into some subnet group, okay? And then I have to put my NACL rules, all of that. I want my Lambda to adhere to those rules as well. In that case, absolutely, I want to associate that to a VPC, right?
Yes.
So that's a first function. This is a Node.js based function. So, right? So what we'll do now is, let's go ahead and create a brand new Java-based Lambda function. So how do you do a Java-based Lambda function? This is how you do it. So this is my Eclipse. Here I created a simple project called Lambda. Okay. So.
Again, I have a question.
Yes.
In the earlier example, we were seeing the logs, and then those were created with, like you're showing in the REST example, right?
Yep.
So is it because even RDS is not going to support for the Lambda? It's not because it's not exposed any of the endpoint as a REST, since this Lambda is all talking in REST. So when we want logs, so it is automatically creating all the REST endpoint that's connected. Is it because all the REST world it is able to talk and then create necessary functions?
So let me understand, Satish, if I get your question right. You're able to trigger Lambda using all of this, but not RDS. Why is that? Is that a kind of question that you're?
Yeah, I'm I'm emphasizing that RDS is not exposed any of the HTTP endpoints.
Right. So
Because
RDS, go ahead.
Yeah, all of the like DynamoDB or CloudWatch logs. Those are the software or services which exposes endpoint.
Yep.
The only reason we were able to make it, successfully connected with Lambda functions. Is that my question?
Yep. That's actually a very good direction. The way you arrived at. Yes. So if you look at it, all of these actually they expose REST endpoints, and these guys can call some of the REST endpoints. So your Lambda itself will be exposed as a REST endpoint, and then these guys will be able to call it. But in the case of RDS, so when I say RDS doesn't trigger the Lambda, what I'm saying is that when a new row gets created, your database has to make a REST endpoint now. You see what I'm saying? And you're supporting those 6-7 database engines. So it is not part of that, because does that make sense?
Yeah.
In fact, you answered the question. I didn't add. Go ahead.
Even we can infrastructure any of the like how we did it for Dynamo. It can be for any Mongo or any non-SQL database. We can do that.
Non-SQL databases, no, you cannot do that.
Okay.
You mean you are creating your own one? Then it's not automatically created. So you will have to come up with your own way of calling that. Does that make sense? Because these guys, this is Amazon's non-relational database, right? So Google actually comes with their own, what Google's default is Mongo now. Google's, I believe it's the default one itself is Mongo. So this is Amazon's flagship database, flagship non-relational database. They only support this one.
Okay.
Because if you have to create Mongo, then how are you planning on creating Mongo? Actually, your question is pretty interesting. So I'm thinking of here.
Suppose he puts that in the EC2 server. I had a similar question. Like suppose I had a Oracle in my EC2 server. I wouldn't be able to do that, right?
Yep, exactly. Okay. So the only option is, I'm thinking out loud here. The only option here is there is no off-the-shelf tool that can provide you Mongo. Then you will have to do it yourself, right? So you have to create what did Amazon give you in this case? Infrastructure service. Well, it gives you infrastructure, do whatever you want to do it. Yeah, install Mongo, sure, right?
Okay.
But will it trigger Lambda? No. Make sense?
With VPC and all that?
It doesn't matter. Nothing to do with VPC.
Okay. Okay. So what I understand is Lambda has got a limited limitation right now.
What do
See,
you
API
mean?
gateway, AWS IoT, Alexa, all these things.
Yeah.
But not anything beyond that of like putting a database on the EC2 server,
Putting a
reading from
database.
there.
Sorry. See, look at this one here. Click on Lambda here, guys. Okay. No, my only point, I think, because it's taken as in a different way, that's why I think I have to correct it. So my only point there is your RDS is not one of them. It's nothing more than that. Okay. So please understand, RDS, when you insert rows, in a database table within an RDS or update or delete, it cannot trigger Lambda. There's nothing more.
Got it.
So,
got it. But not only RDS. If you have a database in your EC2 server, even that you cannot process with Lambda.
of course, yes.
Okay.
Yeah. But go ahead. So if you really want to find out, right, click on add trigger here and then look at all the triggers here. You will understand API gateway, IoT, skill set, ALB, CloudWatch logs, code commits. Yeah, this is your Azure DevOps equivalent. So DynamoDB, EventBridge, Kinesis, S3, SNS. Okay, and these are all the partner stuff.
Okay, that makes sense now.
Okay.
Okay,
guys. So now with that said, does it make sense?
Yeah.
Okay. You have another question, Satish?
No. I'm good.
Yeah, I want to just understand a bit more. This is Manohar.
Yes.
So when you say that database needs to, it cannot trigger a Lambda because during these transactional processes, either insert, update, or delete, whatever that happens, it cannot produce any REST activity. Is that correct assumption? Because of that, Lambda cannot. So Lambda will be only able to work with these things because these other like API gateways and AWS IoT and all, they will be able to provide some feedback as REST, right?
Exactly. That's what we are saying. Yeah. And also you'll have, database engine must provide something, right? Again, your transactionality come into picture, your database engine, all those engines itself have to do it. Because in this case, right, I know we have RDS on top of it with Amazon, but Amazon mostly relies on the database engines. If MySQL supports it, it supports it. Now Oracle, you understand what I'm saying? Microsoft SQL Server, all of these guys have to support it, right? If they natively support REST, then probably they'll be able to do it. But no, at this point, absolutely no. I'm not saying, they might be able to provide it, 5 years down the line, but that's the case.
Okay. Then in that case, one can write a Java program, access the database, and expose the data in the form of web service, and that can be processed by Lambda, right?
Can you repeat that?
See, if one writes a Java program or a Node.js program and read the database and then expose the data in the form of web service, and Lambda can pick that up, right?
Oh, see, this one, please understand, what can you do with Lambda is different from what triggers Lambda. Please separate that. What can you do with Lambda? There's no limit. Can I connect to anything with your Java code, for example? You can connect to RDS, you can connect to S3, get the whole file, dump it into the RDS. Absolutely, you can do it. Similarly, you can call any of the services, you can do anything. But what triggers Lambda? When would my Lambda function be triggered? Automatically when an event happens. Does that make sense?
Yes. Okay. Okay. Two different things. I was confused.
So there is an event happening in RDS when I delete a record in a database table, but that event cannot trigger Lambda. That's my point. But absolutely, your Lambda can go read any database table from anywhere. It doesn't matter whether it's RDS or not. So please understand the difference. I hope I made that clear. Yeah?
Okay, got you. Thanks very much.
Yep. So let's go ahead and create a new Java-based Lambda function now. Okay, with Java, you have to pick up your favorite IDE. And this is a simple Java project. I did it in Eclipse. And it's a Java version 1.8. So AWS has this library called AWS Lambda Java Core. Okay, you can use this one and put it in your POM XML, and that's it pretty much. Let's go and create a simple Java class here. I created a class called handler. Okay, so this handler implements. I can actually delete this guy. Okay, so handler implements, the only requirement is that your handler must implement this request handler. Okay, there is a request handler interface, COM, Amazon, AWS services, Lambda, runtime request handler. And pretty much that's it. And then this request handler has a method called handle request. Okay, it is giving you the complete event in the form of map. Remember, we just saw first name, last name, zip code, the complete, what's the JSON object? The complete JSON object will be converted into map and will give you the event. And then it also gives you the context, the context interface, meaning who actually triggered it, what are all the details around that, it will give you that. So if you want to get the logger around it, you can use your SLF4J, logger factory.get logger. I got the log here, log.info. My first Java function has been called. And then if you look at it, I'm looking for event.get. I'm looking for key first name. I'm looking for key last name. I'm looking for key company. If I get that, then I'm getting my first name, last name, and company. And I'm returning a simple string back. You're saying, hello, first name and last name. So you work for this company. A simple. Okay. Make sense? So now, with that said, I'll just go ahead and run this guy. I will create a jar file. Clean package. Okay, it will be complete in a second. And then meanwhile, what we'll do is let's go ahead and create a new function. Create a function, order from scratch. Yes, my first Java function. Runtime. So I have compiled that using Java 8. So I'll pick up same Java 8. And permissions, you look at it, create a new role with the basic Lambda permissions. When you say basic Lambda permissions, that means basic Lambda permissions essentially means ability to create your log group and log string, and then create function. So now function is getting created. What I will do is, as here, I got this jar file, right? I'm going to upload this Lambda 1.0 shaded jar file into this. You cannot use an online IDE for Java-based applications for a good reason. You can't use, right? Function code. And now, since Java 8 runtime has been chosen, my online IDE, the code editor is disabled. See, the code editor does not support Java 8 runtime. So actions, upload your zip or jar file. Okay. I'm uploading that 6.7 meg jar file. I don't need any environment variables, tags, basic settings. Let's update the basic settings. See, by default, the basic settings is your fully qualified class name, example.hello, : handle request. Actually, leave it there. I will show you what happens. Okay. It will fail, and memory is 512 meg. And I will leave every other setting as is. And I'll create a simple test case. So here I will say, I'll call test, and then key 1, value 1, key 2, value 2, key 3. I'll leave it to start with, and then create this guy. Let's go ahead and test it. There you go. It failed. It gave the error saying class not found, example.hello, I couldn't find it. Makes sense. So let's go to basic settings, edit. What's your main class? What's your handler class name? This is your fully qualified class name, com next step lambda dot handler. Com dot next step dot lambda dot handler. So fully qualified class name, the package name dot class name : method name. Okay. Save. And now let's go ahead and retest it. Let's look at the details. It gave me the response back, this guy, hello, null, now, so you work for now. because let's take a look at your, this is the JavaScript object notation. This is the JSON object we passed it. Key 1, value 1, key 2, value 2, key 3, value 3, right? And what are we expecting from the event? This whole thing is an event. This whole JSON object is passed as a map to this method. So I'm expecting first name, last name, and company. So let's change it. First name, last name, and then company. Yeah. Save it and then test it. Okay, now our response came back. Hello, Venkat Hari. So you work for next step. So you can take a look at the logs. If you want to look at the actual logs that are generated, the complete logs, go to the log groups. And in the log groups, you will see my first Java function and Lambda, the previous one. So my first Java function. And then let me look at the latest one. So my first Java function has been called. That's it. Makes sense.
Okay, if you want to do sysout, can you do that? From the Java?
Sysouts will not be.
Okay. Sysout will not work, right?
Sysouts will not be printed into the logs. Okay, your console logs. Okay.
I guess if you use sysout, that goes to the /user/var logs on the server.
Yeah.
So it's not good to write sysouts.
Yeah.
Yeah.
If you want to use sysouts in any application, they will go to the server logs versus application logs. So use one of the logging mechanism, either SLF4j or commerce logging, log4j, all of that. So okay, that's a simple Java function. So let's complicate it. Let me just pause for a quick second. Okay, so that's a simple Java-based Lambda function. So what we'll do now is, let me show you a little bit, a better Lambda function. We'll close this guy. So this is another Java application. So here I wrote a simple handler also, but this is an S3 event handler. So this is also, this class also implements your request handler. It's the same stuff, but this one, it is giving you S3 event notification as an input. S3 event notification. This can be used in case S3 is the one that is triggering this event notification. Meaning, let's say S3 put object, S3 get object, S3 delete object. In all those cases, you can call your Lambda function. Okay, so this is how it looks, and let me show you actually with by creating a Lambda function. So let's go to Lambda functions, create function. I will call this S3 event function. Okay, S3 event function. I'll call this Java 8. Permission, I'll leave it the default, create a new Lambda row. I mean, I can use the existing one also, but I'll leave it as is. Create function. S3 event function. So with the S3 event function, I can go ahead and upload the code, but that's not the point. I wanted to make configure test events. I wanted to show you, create a new test event here, event template. Pick up S3 event template. Let's say S3 put. Take a look at this one. So for S3 event notifications, this is the kind of request that will be sent to your Lambda. This is the kind of payload that Amazon will send it to your Lambda. Take a look at it. Your JavaScript object notation, your JavaScript object has multiple records. Multiple records are nothing but multiple rows, array of records, right? Each one of them will have an event. Each one of them will have an event. So event source is AWS S3. So AWS S3 is the event source in this case, meaning S3 is the one that is triggering the event. Meaning when I place a file in S3 bucket, this is how Amazon will send the request to your Lambda. Does that make sense? So this is your event source. When did this happen? And what's the event name? Event name is object created : put. This is a new object created. Okay, your HTTP put has been called, your new object has been created. And who created it? All of that. And what's the source IP address, who created it? And also in the response elements, okay, all the details of the event itself, okay, they can be found in S3 object here. So what's the bucket? See here, what's the bucket name of the event that gets that's triggering this Lambda? Okay, meaning in what bucket a new file gets added, and then what is the object details? So what's the file name? This is how it looks. Okay, so I will call this guy, and now you got this whole thing, right? Amazon sends this kind of payload to your Lambda. Now let's take a look at our Java example here. So S3 event notification object is your entire this JSON object here. So now you can say input.get records, you are getting this one here. And then if you're looking for the get of 0, that means first one, .get S3, meaning this here. And if I want to find out what's the bucket name from which the event got triggered, and I can get that. S3.getBucket.getName. See this one, bucket, S3.getBucket.getName. This is the bucket I'll get at. And S3.getObject.key. This is how I get the file name. Okay. Once I get the bucket name and object key, all I'm saying is I'm putting into the log, my bucket name is this one, object key is this one. It's that simple. So wherever the event sources. Okay, whatever the bucket is the source of the event, and whatever the object that get modified or created. So I'm just printing those details. That's all. Make sense, guys? So I will call this unit test case as S3 and create it. And now we didn't upload the code, right? What I will do is I'll upload the code here, run as. You may be wondering, why are we doing this one? I will show you, because I'm just taking a lead here. By showing this example here, I'm just paving the road for my next example, complex example. Okay, so it's stored here. Let me go update the code here. Where is the code? Function code, actions, upload, zip a jar file. It's called S3 event handler 1 target. This guy, save. Okay, and now go to basic settings and give you a fully qualified name, com next step lambda. Your package name dot class name dot method name is handle request. So this is good. 512 MB is also I'm good. Let's go ahead and test it. I'm passing it. I'm unit testing using this S3, right? So I'm passing this entire JavaScript object notation, okay, to my Lambda function, and it will be sent as an object here called S3 event notification. I hope everybody is clear on that. Let me click on test, and I got the details. I got 200 okay, because that's the response I'm sending it back, but I want to see what's in the log. How can I look at the logs? I will go look at the logs. This is my new function, so a new log group must have been created. S3 event function and one log stream. There you go. Handle request has been called. Is that the only one that what did I put it? Handle request has been called, and also I gave the bucket name equal to example bucket, object keys test / key. So these are the details that we gave in our stubbed out request. See, if I change this stubbed out request to bucket name, let's say whatever this Venkat bucket, and then object name as weather data CSV file .csv, then my logs will tell me that. Let's go to, there you go. See here, now Venkat object, sorry, Venkat bucket, and the object key is weather data CSV. So essentially whatever I'm sending it, right? So I'm just taking the lead here, because we will not be hard coding these values in a stubbed out request like this. All of this will be passed by Amazon automatically once you set up your trigger as an S3. That is what I'm trying to get at. Make sense, guys? So I hope you understand this whole S3 event handler and your S3 event notification. I'm getting my bucket name and object key. So with that said, now let me get to the final example. So the final example is the complicated one. Let me close this guy. Let me step back here and give context one more time. The context is we are building a simple weather API. So our weather information is stored in the database. So what I did before the class is I created this RDS database. Where is that? I created a MySQL database. before the class. I called it weather dev. And then there I have a schema called weather. I have a schema called here weather. And there I have a table called temperature lookup. Okay. And we talked about this one before. And currently I have this much data. So what I will do is I will delete from, yeah. Now I'll check, make sure it's nothing there. So let's say that my web API will pick up the weather information from this particular database table. Okay, so I created RDS. And then I put it in a security group that exposes 3306 to the world. Okay, because my Lambda is somewhere else and my RDS is somewhere else, so it needs exposure. Is this the right way to do it? Not really. You want to use ideally the database proxies. Okay, but I didn't use it for this example. But essentially the concept is same. So you have a database RDS there, and you have a database table. So my problem domain is I will get new weather information from government like twice a day. When we get that CSV file, my analyst is going to upload that CSV file into S3 bucket, and I have a S3 bucket here. Where is S3? I have an S3 bucket. Let's take a look at it. Next step, training weather data here. Okay. And properties, let me take a look at events. I'm going to delete this event here. I'll let you know what I'm doing here. So this is my next step training weather data. This is my bucket name, and I have a CSV file here. By default, I will not have, right? So let's go ahead and delete it. So I have an empty bucket here called next step training weather data. Okay. So I'm going to write Java code, my Lambda code. What my Lambda code does is, when an event gets triggered, it is going to take the bucket name and the object key, both of them. So we are going to, Amazon is going to pass both of them, the complete S3 event notification, right? So what my Java code is going to do is, it's going to, using Java code, it's going to connect to this S3 bucket, get the file, get the weather data, and then parse it, and then connect to the weather database and dump the data into the database table automatically. So this is my end user experience. My analyst got new weather information from government. She got the data and she'll go into this S3 bucket. She doesn't know anything. She doesn't know anything. My tester or analyst, she doesn't know anything. So she will just go to upload, add files, and then she will go to my desktop somewhere, and or wherever that weather file is, whether feed.csv or weather data.csv, right? Somewhere there. Okay, I'll find that out. So this CSV file, just upload it. That's all I know. So the way I'm going to set up is that I'm going to write a Lambda, and I'm going to configure that Lambda to be triggered for any S3 events in this particular bucket. That's how I'm going to do that. Does that make sense?
Yes.
I'm just giving the problem domain there. So now let's look at the solution domain. Let's look at this is my S3 event handler too. There is a new Java project here, and take a look at this. I have multiple files here. I will show you the first guy. S3 event handler is the guy that takes a request. Okay.
So Venkat, this Java program is outside of your AWS, right?
Oh yeah, this is my local. This is my local. See, where you coded it, Amazon doesn't care. You just you just compile it, put it into a jar file.
Okay.
Give me the jar file. Upload the jar file. It doesn't matter.
Right. Okay. Yes. Of course. Yeah.
So this is, by the way, this is all in GitHub, so you don't need to worry about reading it. Take a look at this S3 event handler. So I'm taking my bucket name and object key, both of them. These are the two things that I need. My bucket name will be given as next step training weather data. My object key will be whatever the file name that my analyst got it. Okay, but it doesn't care what the bucket name, what the object key is. Do it. It doesn't matter. Okay, and I'm just logging it, and then I'm getting the weather data retriever object. This is my list of weather objects, and I'm asking the retriever to give me the data. So I'm giving the bucket name and the object key, right? So all it's doing is it's using S3 SDK. It's connecting to USEs2, get the object, S3 object, input stream, and it's getting the complete object, my CSV records, it passed and stored, I got it as iterable as CSV records. And then I'm iterating through each one of them. I'm getting a zip code and temperature and creating a new object, populating into it, adding it to the list, and I'm giving it back.
If you had those connection information in properties file, you'd still be able to do that.
Can we say that again?
See the connection information to USEs3.
Oh, absolutely.
USEs2. You could have that in the properties file.
Absolutely, absolutely. That's that's a lead part. Yep, absolutely. And actually speaking, earlier to your question, will sysouts be printed? Actually, sysouts are also printed. Just thinking about it, sysouts will also printed. We'll find out here. Okay, you can put out the. This is, as Satish was saying, this is not at all a good practice. You should never put the sysouts in your code, especially in the production code. You should always put them in, use SLF4J or something. I was experimenting it. You can even actually use this context.getLogger also. But SLF4J is probably better than, for all the people who are familiar with Java, that's better. But let's not spend any time on that. It's a Java specific question. So let's not. Okay. So essentially what this guy is doing is, it's taking the bucket name and object key from the context information from the event itself. So whoever raised the event, they sent me the complete payload, who raised the event, where and all the event happened, right? From that information, I got the bucket name and object key. And now using the Java code, I'm going to that S3 bucket, downloading that file, parsing it into CSV, and then converting them into Java objects and giving it as a list of other objects. Okay. And then there is another service or another repository here. I know I've used this new here. It's not a good way to do it, right? Actually, you want to use a dependency injection, Spring and all. I didn't use it because I wanted to show you in a simplest way. So insert weather data will take a simple Spring JDBC or a simple JDBC. So essentially so this is where all the database information is. Okay. See, this is JDBC URL. Ideally, remember I showed you in a function of, in the function details, there's environment variables. You can use them as environment variables, your driver class name, URL, your username and password. All these 4 should be an environment variables. And then your class should read get property. Okay. So anyways, essentially connect to the database and then insert into that. That's all. Delete all the data that currently exists, and then you insert your brand new records. That's all I'm doing. Make sense? So you can have your Lambda as complicated as it can be. This is what earlier, this is why I was asking you guys to kind of, who can trigger Lambda is different from what Lambda can do. Lambda can do a lot more. This is all Lambda. Lambda is actually connecting to the database. Lambda is connecting to S3, getting the details, parsing it, converting into Java objects, and then passing it to your another object. Make sense? So with all of that, if you guys are okay, let's run it as I'll do a clean package and I'll skip test. So I'm building the jar file right now. Let's go ahead and while that is getting built, let's go ahead and create a new Lambda function. Yeah. Click on Lambda, create function. I'll call this as a weather Java function, weather data load. Yeah, that's right. Weather data load, probably that's better. Runtime is Java 8. Permissions, I will say create a new role with basic Lambda permissions. Okay. I will start with that, but I want you to understand one thing here. My code here, when I'm retrieving the data here, I'm not using any of my access key, API key and secret access key. I'm not using those details here. Okay, I'm going to give my Lambda full S3 permission. How can I do that? I will show you in a minute. But understand that my Lambda does not have any information about these API keys, secret key and your access API. Okay, just keep that point. I will show you. So create a new role. Sure, no problem. Create function. So it's creating the function. Now function code, let's go ahead and upload the jar file. S3 event handler 2 target, and then it's an 18 meg file because I added Spring JP, not JPA, but Spring JDBC and a couple of other libraries. That's why the jar file is pretty fat. What Amazon recommends is if it's larger than 10 MB, drop it into S3, and then you can upload it. Okay, my code has been uploaded. I don't have any environment variables here. My basic settings. Let's go.
So 1 second. So drop it into S3 means upload to S3 the jar file.
That's correct.
And then from there you would really pull it into here.
You can do that. My fully qualified class name, your package name, dot class name, colon, method name. Yeah, save it. VPC file system, everything I left it as is, Let's go ahead and test it. It will fail, but let's use my configure test events, and I want to use my S3 put this guy here. Okay, I know it's all unit testing. It's not the real data. We did not plug these. We did not plug these Lambda functions with any triggers yet. Okay, I want you to understand that. We are only unit testing our piece at this point. Okay, so let's go ahead and test it. It should fail because my Lambda should not be able to connect to S3 because it doesn't have any details. The bucket is in this region, US East 1. Oh, you know what happened? Go ahead and look at the configure test events. It's saying example bucket. So somebody has taken example bucket, right? Example bucket is apparently US East 1. So anyways, the point is, let's go and go to S3 and let's give our details. This is again unit testing, guys. This is my stubbed out information, okay? This is my stubbed out information, and my file name is, I will upload the file for now. Okay, I uploaded the file, and let's make sure, because there is no trigger, there is no Lambda here, I still have 0 records in my database table. Okay, very good. Now, this is my file name. This is my key name. Let's change our details here. So this is my bucket name, and this is my file name. Okay, and these two I'm passing it as a test data. It's a pure test data, guys. Okay, we didn't attach the triggers. Hey, it failed. See, it said access denied, so it should fail. So your Lambda function could not connect to S3 and get the object that we gave, whatever the next step training details, this particular bucket, this particular object, it was not able to retrieve the data because this is a private. See here, access denied. So what we will do now is, let's go and, we gave some permissions to Lambda, right? Let's go to Lambda permissions. This is the role name. This is the role that's been created as part of creation of your Lambda function, right? And by default, it only has one policy. This is AWS Lambda basic execution role, which means that creation of your log group and log string. That's all. Okay. So what we will do is, let's go to the role again, and let's add an additional policy here, attach policies. I'm giving Amazon S3 full access. You don't want to ideally do that. You want to create your own custom policy and attach it, but I'm attaching Amazon S3 full access. Okay. Now I'm unit testing it. Can I go ahead and unit test now? I'm still unit testing it, but my unit testing will trigger Lambda. There you go. Unit testing, trigger Lambda. See all of this information. My object size is 10. Apparently I have 10 objects there. Whether object size is blah. These are the zip code details, all of them. Apparently this is the zip code, and this is
one question about this unit test. See, your Lambda is supposed to be triggered on the S3. That means S3 event. That means when you drop a file, but you've already dropped it before. So you have to delete that and drop it once more, right?
Absolutely, we'll do that.
Okay, but then how is the unit testing, or you are unit testing?
This is my unit testing, meaning I'm triggering my Java class pretty much. I'm testing my Lambda function. Does it make sense? I'm triggering it because it does. What happens when you upload a file in that specific bucket? What happens? Your Amazon will send this particular file to your Lambda function. That's all it does, right? I'm faking it. I'm mocking it. I'm stubbing out. This is a stubbed out response. Sorry, stubbed out request. Does it make sense?
Yeah.
I am invoking Lambda manually by sending this stubbed out request. Does it make sense? So, and you can even see in your unit testing that your data has been created. There are 10 records. So to Shovan's point, let's go and delete all the records. Okay, I have nothing here in the database. I've deleted it because my unit testing, through unit testing, I verified everything is working fine. Okay, my end-to-end. But the only thing that's missing is it's not attached to the trigger. My function, my Lambda function is solid. It's beautiful. There are no problems with my Lambda function. It just needs to be attached to a triggering event. Once I do that, and once I upload a file, then it will magically work. We will see that. Let's go to functions. So unit testing is all beautifully done. It's called weather data load, right? Okay, what I will do is first let's go to our
S3 bucket.
S3 bucket, and I'm
Delete that. Yeah, I'm just predicting.
Yes, sir. I'm deleting it. And still, you should have the same thing. 0 records. Beautiful. Okay. Now, this is my next step training weather data. This doesn't have a file. My Lambda function is all good. Let's go to Lambda function. My Lambda function is solid. The appropriate permissions are given. It's able to connect to the database. I tested every single piece, right?
See, but the deletion event would also trigger the same Lambda, right?
You are totally right. But there is no Lambda attached at this point.
Okay.
You're totally right. We can do that. So go to your functions, go to designer piece here. Now our weather data load is sitting here. Let's add a trigger here. So add a trigger, go to S3, and you can specify what bucket you want this to be a source. Next step training weather data, and event type. All object create events. See that? All object create events, meaning whether you create the object, whether you update the object, whether you, all the object creations. And if you want to, if you want to trigger delete events, then you can pick up this one. All object delete events. Okay, I'm only doing it in all object create events. Make sense, guys? And do you have any specific prefix? No. Any object creation, I want my Lambda function to be triggered. Any object update, I want my Lambda function to be triggered. Okay, I don't have any prefixes or suffixes. Enable trigger, go ahead and add. Configurations, and the same bucket cannot share a common event type. Okay, let's go. When creating the trigger, configurations overlap. Let's go take a look at, where is my S3? This is my S3. Let's go to properties and events. Yep, there is already an event that I created. So I'm just deleting it and saving it. That is the error it was throwing, saying that you cannot have same event again. So now go back. Add trigger, S3, bucket weather data, all object create events, click on add. Beautiful. Now take a look at, graphically look at it, guys. Your S3, this particular bucket, when any of the object creation event happens, this will trigger your Lambda. Does it make sense?
Yes.
Of course, your Lambda can trigger something else, and that's where you will add destination. Your Lambda can trigger another Lambda. Then you can keep going. Make sense? Now we are all set. Now, before we do anything, let's make sure that we don't have any. Yep, still no data. So our analyst came in, or I'll leave. Our analyst came in, and analyst has no clue. All right, just move it here, not it here. Okay. Our analyst came in. She's a non-technical person. She went into S3, went here, and no objects here. All she does is upload objects and then go to weather data. This is what she got it at about 11 o'clock from government. Upload, that's it. And just wait for magic to happen. Keep Looking for this? There you go. Already happened.
Venkat?
Magic already happened. Yes.
Venkat, one question. This is Ramesh. So I think I missed one point here. Like now the bucket, whatever we are using is not public, and the object also is not public, right? It's private.
That is correct.
Then where we have mentioned that security access keys.
Yep. We did not mention security access keys in the code. So what we did is, so you have two ways before. I'll answer your question. Give me 1 minute, okay? First,
Okay.
let's make sure everyone is clear on this, guys. Is it clear? So, and you can do this one. You can go ahead and delete it. You can go ahead and delete the data. Okay, and then nothing, right? So now you just re-upload one more time, and then just wait.
Venkat, you can have 2 SQL sessions. Better for you. You don't have to type this all the time.
See that?
One for delete, one for.
Oh, I see. Okay, yeah. Thank you. Make sense? That's it.
Yeah.
And you can verify all of that through your go to services, or actually I'll go here. Go to services, and then go to CloudWatch, and then go to log groups. And then where's my weather guy? Weather data, this guy. And then there you go. There you go. It triggered a couple of times, or 3 times precisely, because 1 time we unit tested it, and 2nd and 3rd times through the actual event. Handle request has been called. Bucket name is next step, training weather data. Object is this one. Weather object size is 10. Weather object size is 10. Driver class name.
Venkat, did you do anything for setting up for the CloudWatch?
I did not do
Okay.
anything.
Okay.
That's a good question. Let me answer that also. So first, make sense here?
Yeah.
See it? And also it tells me 500 milliseconds, memory size 512 MB, max memory used is 158 meg. So only 158 meg has been used for this particular Lambda. Okay. So I'm just printing, probably I'm not a prudent logger here. I should not do this much. This is a exhaustive logging. You don't want to do that. Okay. Anyways, so what did I do to get this? Nothing. Let me show you, and then I will get to Ramesh's question. So when you create a function here you give your, see here, choose or create an execution role, right? When you said create a new role with the basic Lambda permissions. Okay, those basic Lambda permissions are nothing but, giving access to be able to create a new log group and create log streams. That's all it is. And then you'll be able to do it. You just keep writing through application and you'll be able to see it. Does that make sense? So go to functions here. So go to my first Java function. You can take anything and go to permissions here. And then this is the role that's been given to your Lambda function. So whatever policies have been attached to this particular role, your Lambda will assume all of that. So your Lambda will be able to do all of them. So click on this role, and then you will know that this role has one policy, which is AWS Lambda basic. Sorry, this is the role. This is the policy name, right? Yes. So look at your policy editor, and you will see that allow create log group, allow create log stream. Okay. And this particular resource. So resource is your Lambda function. Make sense? So now going back to
one quick question.
Sorry, if you don't mind, please hold your thought. Let's go back to Ramesh's question. How is this Lambda? So his question is, how is this Lambda being able to connect to the S3 bucket and download the object? It's a private bucket, private object. How is it able to do it? Well, traditionally, we were giving the access key and secret access key. So where are we giving it? Well, you can skin this in two different ways. One is, when you do this one here in the code, when you said get weather data, here you can do your setters. Okay, you can do your system.properties, right? So you can do that. That's definitely a workable solution. Is that a good solution? Absolutely not, because you're putting it out in the code. So you can actually, there are three ways you can solve it. One is this way, the code way. The second way is go to your environment variable, configure them in the environment variable. These environment variables are available to your code as system properties. So your code can get them and then use it. Or the third way, the best way is your Lambda function is a piece of code, right? It's a function, and you can attach the roles to it, and you give the appropriate role to that, or give the appropriate policy, attach appropriate policy to that particular role that your Lambda is assuming it, and then it will be able to connect to it anything. So go to permissions, see my weather data load. If you look at it, permissions, and this is the role that's been created. And I went there and see here, one is it has a simple Lambda basic execution role, and it also has Amazon S3 full access role. That is why it's able to invoke it. Make sense?
Yeah, thanks, Venkat. Yeah.
So Manohar, go ahead.
I think the question is answered, because it's all like my question is, these are all Lambda functions and all are account associated, right? When I log into the system, it is associated to my account.
Absolutely, sir.
So whatever the IAM roles that I have,
Yes,
they will be applicable here.
those are all interlinked. Yes.
So okay, yeah.
Makes sense. So if you look at here, you have 4 functions. One is Node.js, and 3 of them are Java 8 based runtimes. Now, I wanted to make this weather data load, or the whole weather service, right? I wanted to make that serverless, but it is serverless to an extent, but it relies on RDS. RDS, I can't call that as a serverless, because there are servers underlying, and I'm paying 24/7. If you look at RDS, for example, go to RDS, this particular database that I created. This particular database that I created, I will have to, so it's a class is db.t2 micro. I know it's free for 1 year, but I will be paying, otherwise I will be paying 24/7, 365 days, right? I don't want to do that. I want to rather use a serverless. Of course, I can go with serverless relational database. My Amazon Aurora, I can do that. Or I actually want to go with the non-relational database. That's even better. Okay. Single digit response times. Who can provide a single digit response, single digit millisecond response time? It's especially in the Amazon world, that's, go to the database, and that's your DynamoDB. So here in the DynamoDB, you look at it. So I have a weather database table here. I can even actually show you how to do that. create a backup before deleting. So in the MS, so the only thing that's a server, sort of server here is RDS, right? So I rather want to use DynamoDB. So especially it makes perfect sense for unstructured data. It's perfect sense. Okay, let's say in this particular use case, I have my zip code is my primary key. Okay, zip code is my primary key. Let me show you. Let me open up a simple notepad, because I'm going to give this to you as a homework, but I'll show you. So zip code is my primary key. So let's say my zip code is 48083, and here I can have a data like, I can have data temperature, I can have humidity and more. Okay, let's say temperature and humidity. Let's pick up one more 48456. Let's say that's a zip code. And here I get temperature, I get humidity, I get air quality, I get, what else? Precipitation percentage, precipitation.
Wind velocity.
What is that?
A wind velocity.
Wind velocity. So I have this many pieces of information. See, now this is, if you want to store this kind of piece of information in a relational world, what you would do is you will create a table called weather, okay, or weather data, and then you will have multiple columns: temperature, humidity, air quality, precipitation, wind velocity, and more. When a new property come in, then I'll have to change the structure of the database table. Then I will have to add a new column, which has its own ramifications, right? But if you go with the non-relational database, you can just say that zip code is my primary key, and this is just an additional items. You can have as many items as possible. Sorry, each one of them is actually a row, right? This is a row, this is a row. So with this database table, I'm kind of trying to put this in a non-relational terms, right? So I'm creating a new table here called weather. There I have multiple items. This is one item okay, when I create the table, I will say that my zip code is just, zip code is a primary key. That's all. So this is one item, meaning one row. This is the second row. And you can have a third row with 100 different properties, because the complete JSON object can go into that. That's all. Then I'm not changing it. I'm not changing the structure of the database table. My code will work perfectly fine. Does that make sense? So I'll show you. Create a table. Let's say I'll call this weather itself. Yeah. And what's your primary key going to be? Zip code itself. And then if you need an additional sort key, you can do that, or use the default settings. Let's not use the default settings. Okay, let's not use the default settings. Let's go to, if you have any secondary indexes, you can add it. And read write capacity mode. Take a look at this one here. So you have a provisioned read write capacity mode. This is a free tier eligible, or you can go with the on demand. So if you go with the on demand, the beauty is that, outside of the free tier, right? So you have a beautiful idea on this weather service, and you want to build a nice weather mobile app. You don't know if this idea will kick off or not. So you can definitely go with the provisioned route, with the provision route, what you're saying is, you kind of know what your capacity is. You're saying that, hey, I will get up to 5 read capacity units and I need up to 5 write capacity units. And you are about paying $2.91 per month. Okay. You can even, go to capacity calculator and see, you will get it. Average item size, meaning average row size. Average row size, let's say 5 KB. Okay, and then let's say you have about 10 reads per second happening and 10 writes per second. Then you're paying $25 per month. 10 writes per second. Imagine that. So let's say you start and your company gets, your idea is just getting kicked off. So you can, all your requirement is 1 read per second. This is an average, right? 1 write per second. And each row is about 5 KB, then you're paying $2.52. So this is how you can say that 5 read capacity and 5 write capacity, you can pick that up. Or if you do not know, absolutely you have no clue how much, what your scaling requirements are, then go with the on-demand. If you go with the on-demand, then pretty much you could be getting 5 requests for the whole 24 hours for your database table, or 5 million requests. It will automatically scale, and you don't have to. Even provision will scale automatically. Don't get me wrong, okay? Even provision will scale, but you'll be paying little less with provision because you are kind of guaranteed. This bill is guaranteed, because Amazon will be getting that bill, guaranteed. But more than that, see here, auto scaling is there. Target utilization. So when 70% reaches, then it will add 5 more units. Okay, and you can go up to from 5 to 10 to 15 to 20. You can go like that up to 40,000 units. Of course, you can mess with these numbers. Okay. And each capacity, how many units will it give? There is a documentation out there, and DynamoDB pricing page. This will give you what's the each capacity will give you, and you can go to the go read about it, and you can look at it. But this is more than enough. 5 capacity units, I think. This is on demand. This is a provision, right? Go here. So you'll be able to build, you can actually, basic example, see this one here. So if you can get for the month, let's say on day 1, day 1 to 10 is giving some nice examples here. So you're getting 10,000 requests per second. Sorry, is it 10,000 requests per second? No. This example demonstrates how pricing works. Yep, for the first 10 days, assume that the consumed RCUs and WCUs vary between 1 and 70. So this is based on how many read write requests. There you go. So you can look at how many do you, what's your write capacity units and read capacity units, what's your bill is, and then there is a read capacity units, write capacity units. How many do they give? How many reads per second will it give? It's all there actually. Okay. And then if you want to look at the on-demand pricing is also there. Go to basic example and then see here. So if you're, let's say you are writing 100,000 writes. Okay. So for first 10 days, you are writing 100,000 writes, and then 11th day, you got 2.5 million writes, and 12th day to 30th day, let's say you got 950,000 writes, 50,000 average times 19. Yeah. So this one is 10,000 writes per day. Okay, this is 50,000 writes per day. So overall, you got what, 3.5 million writes, $4.44 you're paying. 3.5 million writes, you're paying reads, and you're paying 89 cents. Can any database be like that in the world with a single-digit millisecond response time? You're doing it 3.5 million writes with 3.5 million writes. You're paying about $5 a month. Imagine what happens with your RDS. Okay, you'll have to pay. You'll have to kind of provision a big fat server, and you have to pay all 24/7 for all 30 days, 31 days. Okay, you'll get a big bill, almost close to $1,000. So anyways, point is that, so I don't want to use provision. I want to use on demand, and let's use the server side encryption. I want to use default. So this is my table got created, weather table. And now it's, I know it takes it's a minute or so. So after that, pretty much items are your rows. Okay. So you can create a new item. So you can say now, let's say 48083. 48083 is my zip code. And then what's the value? Let me put it in a text. And then here for this, I can go with another JSON object here, right? Now here I can say temperature is going to be 45 F. Okay. Air quality. I don't know what air quality will be measured in, but good, bad. And what's the other one? Wind speed. 60 miles per hour, let's say. Okay, this is one item. It got what happened? Maybe it's not created yet. For 084, let's say test, and then let's try saving it. No, not sure what the problem is. Maybe it's still getting created. Very good. Okay. Why is it throwing an error? Maybe because my previous, the weather table was not completely dropped. That's what I'm assuming. We can create a new table. Temp lookup, something like that. Zip code, default settings. I can go with default settings. Not a big deal. Just price I wanted to show you, right? That's all. So what I wanted to, the reason I wanted to show you guys this one is, the whole concept of interesting. What did I give at the time of creation? Did I, at the time of creation, let's do did I give a string or what is that? Let me call it temp lookup. Yeah, I gave string, right? Yeah, not sure. It is a string. Yeah, it's pretty interesting. In fact, this is not my goal. My goal, I wanted to show you guys how to create an item. Why? Nothing wrong here. No, nothing wrong really here. Okay. Let me take a look at it. But sorry, that's not the point anyway. So I wanted to show you guys, how do we, I wanted to attach this one to the original problem statement, right? So I want to take out my RDS and I want to create that using the DynamoDB. So create a new table, you can create items like this, but this is okay. This is not what we're going to do anyway, right? I want to use my code to create the new rows here, right? So I want to enhance my Lambda function. My Lambda function, rather than after parsing the data, again, going to the S3 bucket, get the data, parse it, all of that is same. But after that, it has to write it into my DynamoDB, not to the RDS anymore. That is what we should do it. Only this piece will change here. Only this piece will change. See this one, weather data repository. Repository is also fine, but insert weather data has to be modified to not write to that, but write to our DynamoDB. So that is the homework I wanted to give it to you guys. Okay, and all you need to do is just use this for Java people, AWS Java SDK for Amazon DynamoDB. So you just put this guy here in your POM XML, you're all set. And how do we do that? See here. So you just do a Amazon DynamoDB client builder.standard with endpoint configuration, sure. And you get your Amazon DynamoDB .get table, movies, okay. Ours is weather. And then you can create, primary key here is with year, it seems. And then, you are creating a map essentially. So you're creating the JavaScript object notation or JSON object with all of this one. And then you just say table.update item. That entire data will go into that item nicely. Okay. And then actually you can, there is an example for delete also. Delete an item. See here. So essentially delete item spec. You're giving what do you want to delete? I want to give me an item based on year and the title. I'll give that. And then finally just delete it, table.delete item. That's it. So using that, I want you guys to create this whole weather table and then change the Java code that I wrote to point to the DynamoDB and start using that for a complete server-side experience. Complete serverless experience. Any questions? Can you guys do that? I typically give homeworks, something like whatever I did, I ask you to do it. But this time I'm asking you to do extra. So you create a new table in your DynamoDB, because having that experience is also important from, as a cloud architect. Forget about the exam. Yeah, exam also, it's kind of needed. Exam perspective, you'll get confused. Sorry, he will try to confuse you with DynamoDB and your Amazon Aurora, what's relational, non-relational, all of that. Okay. With that, that's all I got from Lambda and such. Okay, guys, have a fantastic day. Let me stop recording.